Hi, I'm Spencer Krause. I've been building robots for over 20 years. In that time, I've seen a lot of interesting things, and I've heard a lot of interesting stories. Collaborative with Spencer Krause is a place where my colleagues and I can relax, crack a drink, and talk about some of the crazier things we've seen at work and some of the experiences we've had that have gotten us to where we are today. Subscribe today to join the collaboration. Welcome to the Collaborative Podcast. I'm your host, Spencer Krause. Our guest today is Diego Juliano. Diego is a Senior Robotics Engineer with Shell. Diego, welcome to the pod.
Oh, thank you. Thank you. Well, it's first time around here and I'm really glad. I'm really welcoming your invites in here. I would say it's the first time I'm on a podcast ever. And I guess the subject is really interesting. It's robotics. So I said, well, why not?
I
So
appreciate you
thanks.
making it on.
Yeah. Thanks a lot for the invite.
You're welcome, sir. It's good to have you on. I'm just excited to be hanging out with you again. We always have a good time. And to your point about robotics, I feel like it's something we're both very passionate about. So it's easy to talk to you about. The conversation flows very smoothly every time.
Yeah, I guess so. Yeah, and it's something that's in our say day to day in many different ways, and it's growing and it's growing even outside of my work life. It's quite hard today not to open up Instagram and see robots there, or open up LinkedIn and see robots there. So robots are everywhere. So I sometimes it feels like I'm working 24/7, just looking at robots and looking at everything that's coming up all the time. Things that coming up from the other side of the world. And yeah, yes, robotics are actually a part of me feels like I'm really embracing change here with robotics.
That's awesome. Do you think that stuff comes up on like you're in my socials because we're roboticists, or do you think that's just like it's just prevalent in the world right now in general?
Well, I would say I may be seeing more robots than other people do, but still, I think even talking with my brother, he's not working with robotics at all. He's an actor. He comes up and he sends me robotic stuff sometimes,
Yeah, well,
because
my
he knows
parents
I'm
do.
working with it. Yeah, you see, so he's also getting it, and all these robots that can dance and do fancy stuff. And I'm here thinking, well, those robots, I'm just gonna give them like a bucket of paint and a brush and get them to paint some pipes and do something useful. But they're quite cool. Yeah.
No, it's funny. I have the same reaction a lot of the time when I see like an entertainment machine now. And I used to work in entertainment. Like one of my first robotics jobs was at a company called Deep Local that did like just entertainment machines for like advertising campaigns. And now that I work in industry, I kind of look down my nose at it a little bit, and I think, well, why? Yeah, exactly. Why don't you do something useful? Get a job, robot.
Get a job. Don't go on dancing. Yeah.
Yeah, why are you dancing when you could be painting?
Exactly. Yeah.
Scrubbing,
Sanding a pipe.
sanding. Yeah,
Yeah.
exactly.
Yeah.
Wire brushing, corrosion, welding. There's so many useful
Exactly.
jobs for robots. So
Yeah, and I mean, yeah, humanoids in general. I mean, now here we are, kind of generalizing robots as if they all look humans, right? I
but that's
mean,
the ones that are in the
90%.
news. Let's be honest. Like those are the ones that our families sending us, like that aren't roboticists. I feel like.
Yeah, it is. It is. Yeah, I would say 90 plus. Actually, almost 100% of my day job is not humanoid
Same here.
related
Yeah, I've
at
never
all.
worked on a humanoid in my life.
Yeah, it's so. I mean, I guess we gotta find so many tasks or focused tasks that really we're trying to find places where humans are not great. So uh, so things like that repetitive things that are. I mean, you gotta climb up somewhere. Things where places where people would have to get into. I don't know, like a pressure vessel or tank.
Yeah.
I mean, so with that said, why would I be designing a robot that looks like a human if a human is not designed to go into these places? So I guess we just design robots to go into these crazy places where humans don't go. But okay, I take the points of humanoids. They can be really useful in a short time frame where human goes to. But I guess first priority today for the industry has been, from my perspective, going where people don't go, you
Yeah,
know.
for sure. And I mean, SK Robotics' mission is to automate the jobs people can't, shouldn't, or don't want to do. And most of those are not suited to the humanoid form right now. I mean, I think as the algorithms develop, we're going to see, more real adoption of humanoids like in the next like 10 to 15 year horizon, probably. But
Yeah.
yeah, I don't know like right away if it makes the most sense. And there's still things you wouldn't want to do with a humanoid. Like, I mean, there's robots that, you've told me about, that I don't know how much of your work you're allowed to talk about and how much you're not, but I can say like the bolt tightening robots we made for Siemens Energy that go like between the crack and between the rotor and the stator and gigawatt generators. Like a humanoid couldn't do that because a
Not
humanoid
at
doesn't
all.
fit in
Yeah.
like a 2.5 centimeter crack.
Yeah, not at all. I guess one of the interesting projects I've been working on here is, I mean, in general, it's soft robotics. It's basically trying to learn from nature most times, but not in human ways, if you know what I mean. So experimenting with soft say tissues or materials is something pretty interesting and has been quite rewarding, I must say, because when you think humanoids, I mean, they are hard. You think of a, a robotic arm of any sort, those arms working at car manufacturing facilities, they're great to what they do. But really, when you come into industrial facilities and you really want to have robots cooperating with humans, having a soft approach, is a very interesting path to follow. And it comes with working with fiber optics and sensing in different ways as well.
Oh,
So
cool.
I see there's an interesting future to it. It's not so prevalent at the moment, but it's something that I'm really keen to learn more about and keep developing on. You know,
That's awesome. And we have done a bit of soft robotics work, so that's cool to me.
which is great. Yeah, I
Yeah.
mean it's different. It's
It's it.
different
Yeah,
in
it's
many
cool. I
ways.
mean, it's like you can have like this inflatable like bouncy castle robot, that all of a sudden like deploys to an area, or like you get like
Yeah,
an elephant trunk, for your actuation. Like there's some really
elephant
interesting.
trunk. Yeah, yeah. And I mean, if we do a lot of work underwater with remotely operated vehicles. So yeah, so elephant trunks can suddenly become a tentacle of some sort,
Nice.
and it can help you with manipulation, or it can help you with a camera on the tip, just giving the ROV operator a different view. So in many ways, I think the robots we're doing today, they really are not here to replace people. They really here to become tools to help our people be more efficient, and people be more efficient in many ways, right?
Yeah, for sure. And I mean, you and I have had this conversation over dinner like a bunch of times, I think, where it's like, they're tools. And I'm like, yeah, they're tools. That's how I look at it too.
Yeah, yeah. Sometimes I mean, if we try to start from scratch, developing a new vehicle, a new robotic vehicle, then it takes quite a long time. But as you are looking at robots as being tools, as being, I mean, so maybe it's just a payload to another existing robot, or it's just a payload to a human being, then it suddenly becomes much easier to develop, and within a much shorter time frame, you can be delivering value to other people, to other operations team, being them on an industrial facility or not. So yeah, robots as tools is an interesting subject for sure.
Yeah, I mean, the other thing is it's like the difference between like a teleoperated system and a fully autonomous one in terms of development timeline. Like it takes, I mean, every roboticist knows like autonomy is just, it works, but it's capital and time intensive to get it to work. And like
Yeah,
most of that's like, it's like 80-20 bell curve stuff where like to get it to work, like, in like half the cases, like that's not so bad. To get it to work in 80% of the cases, like that's maybe like 20% of the work. But then to get it to work in that last 20% of the cases, and as you approach the long tail, it's like worse and worse and worse until you get to like where the self-driving car companies are, where they're trying to get as close to determinism as they can on a crowded city street, and they're spending billions of dollars U.S. dollars trying to do this, and it's just I mean, I don't know. Have you ridden in a Waymo yet? Have you had a chance?
No, I haven't, but I've led some autonomous vehicles developments before,
Oh,
so
nice.
I have some insider perspectives I can share here.
Can I say where you
I
worked? Can
guess
I ask where you worked on that?
no, it was here. It was in partnership with a few companies
Oh, cool.
and research institutions. Yeah, it was the robotic vehicle in this sense. It was a submarine.
Oh,
Put it
cool.
like
Okay.
this.
Awesome.
Yeah. So it's not something that navigate. It's not something that has to ride on the streets, right? It's not something that will collide with people in any way, because it's just meant to be operating at a very, very deep location, so it's
Nice.
a submarine. But still, autonomy is an interesting subject, because you can be spending millions of dollars in making something very, very, very intelligent and not get anywhere.
Sure. Yeah, absolutely.
Yeah, because you can be. I remember finishing a phase of a project, and the guy and the contract had something written like, "Okay, you got to deliver everything." That was some 10 years ago. You got to deliver everything to us in paper, like printed, and in a hard drive. And then the guy was like, "Okay, do you really want me to print all those pages of code?" Because autonomously speaking, there was like huge piles of papers and dozens of people putting effort in writing code into that robot. But anyway, our contracts have changed. People don't ask people to print stuff anymore. But still, if you can spend millions of dollars in doing autonomous, intelligent stuff, decision, and if you miss a little detail on, am I using the best sensors, or am I getting the best hardware for the tool, then you certainly run a risk of getting into a loop situation where you get software people trying to fix hardware stuff or hardware issues, and then off you go. So you have a part of your team developing real hard autonomy related stuff, and the other part of your software team is just trying to fix the shortcomings of the hardware guys. And then you loop into, okay, now scrap it off, throw out your
No, that's all right. We got
your
a good
hardware, your
sonar now.
prototype.
Yeah, exactly.
Yeah, exactly. And then exactly, now you got a good sonar, and now, okay, transform all your software to work with this
You
new
can't. None of the
sonar.
data is valid anymore for the way we're processing it.
Exactly. So yeah, so the technology evolves so fast that if you've made bad decisions, you may have invested a lot of time and effort in nothing. I mean,
Yeah.
you may have created a lot of knowledge, but anyway, I'm glad on that project we made good hardware decisions. We really advanced. Yeah, we really advanced. But looking at other industry peers, I've seen that there were some people that they were not people, but projects that they didn't evolve with a similar pace, and I can say I blame it more on hardware than on software, because they had really good people on the software side.
This episode of Collaborative with Spencer Krause is brought to you by Rockwell Park. If you're building something in tech, robotics, AI, or even advanced manufacturing, Rockwell Park is already home to companies just like yours. Located right here in the historic East End of Pittsburgh, Rockwell Park has spaces starting at 1,000 square feet all the way up to over 100,000 square feet. So if you're an early stage startup or even a Fortune 500 company, here you can scale without limits. Look, we built this studio in Rockwell Park. We love working with these guys. You should check them out. If you're interested, go to rockwellpark.com. Collaborative with Spencer Krause is sponsored by SKA Robotics. If you're in the market for elite field robotics expertise, please consider hiring SKA Robotics. They sponsor this podcast and solve some of the toughest engineering problems in the world. SKA Robotics can be found at skarobotics.com. I feel like there's a few reasons why that happens. So, like, one is a lack of systems engineering, which, I mean, that's just kind of like, whoops. Another one I think is like almost too much cost sensitivity on the front end for like a small number of like first, second, third, fourth, to like low nth articles. So if you're trying to use like, inexpensive sensors, but like before you've figured out how to make it work in the first place, I feel like that's where people spend a lot of money trying to software engineer around an inadequate data set, and they just end up with, having to redo the work because they have to, it just doesn't get you there.
Yeah, it
So,
doesn't get you there at all. Yeah, and I think even with data set, I had some experiences with creating data sets, not from real experience, but actually just creating them artificially.
oh, cool.
And yeah, so we had well, I was in a project that we had to scan some stuff on the seafloor, and we wanted to find some stuff on the seafloor with a type of sonar. And I mean, we just didn't have a lot of examples of that sonar being used before. I mean, it's top notch, no one has access to it. And I mean, we may have ran it a few hours, not hundreds and dozens of thousands of hours, not enough to create a good data set. My experience with that was, I mean, I was working with a university on that time, and the guys were really good in generating these artificial, say, data sets. And we got to a point that we got some SMEs, that's subject matter experts in what we wanted to find, give him the original images and the ones we created, and ask the guy, so what is real? And that was a short time frame. It was maybe like 3 to 6 months in generating these artificial data sets. The guy
Cool.
couldn't tell it. The
Not with
human
this, an
being
SME
couldn't
couldn't
tell it.
tell.
No, the SME couldn't tell it.
That's
And
awesome.
yeah, that's awesome.
Yeah.
And yeah, so we could run the rest of the project using that artificially created data set, and we are happy with the result. But something unimaginable a few years ago, it wouldn't happen.
Yeah, for sure. No, it's incredible how much that's evolved. Like I do remember, even like 5 to 10 years ago, definitely 10 years ago, I was really bearish on the idea of using synthetic data, and it's come so far, and it's like, okay, it's a pretty valid substitute now. But you do get burned, or you did get burned in those days at least, by like some shortcoming in the synthetic data where there'd be a difference that wouldn't be accounted for. And you still see it sometimes. I mean, when we were building that corrosion detection algorithm, we trained that on synthetic data first, and there were some shortcomings that we had to use real data to overcome, and at least the synthetic data we were ingesting. I'm sure we could have gotten better synthetic data.
Well, yeah, and there are things that it's just for a matter of access. So how do I access the ocean floor at 10,000 feet below the waterline?
Yeah, it's gonna be
That's
very expensive.
uber expensive. Like, I don't know, like $100,000 a day expensive kind of thing. And for some other things like corrosion, then it's much easier. You can find a bridge
Oh yeah,
somewhere.
there's corrosion, and living in Pittsburgh, Pennsylvania, in the U.S., there's so much of it.
Or fly next to a shipyard where the guys are actually revamping some, old vessels there, and then off you go, lots of corrosion. But anyway, we always get to the issue of, can we film it or can we use it, and so on. But I guess, yeah, times are evolving. It's ever changing, and now people saying that data is mine, and mine, so I don't want to share because I think there's value in it. One of the things that I really believe is, it's data is worth nothing if you do nothing with it.
Well, it's like the same
Yeah.
argument for intellectual property, I would argue.
It is, yeah. It is, yeah. If you do nothing with the IP, with the intellectual property, then it's just a wasted money in depositing patents, and for instance, and so on, right?
Yeah, no,
Yeah.
some people will brag. They're like, I've got 100 patents. You're like, well, how much are you collecting in
Yeah.
royalties every month? They're like, nothing. That's what I thought. Or
Yeah. I like
Yeah.
it. I could be making, inventing the crazy new mouse, and and deposit a patent for no reason. I mean, no one's gonna change.
I'm gonna invent a
the-
mouse
the-
for an octopus, since we're talking about tentacles.
Make it really clear, yeah,
Yeah.
and invest a few $1,000s in depositing that patent and keeping it alive for the next 20 years. And yeah, I guess, I mean, some companies will do it in depositing patents on great ideas. And when you try to check it, they end up really, say, high level, and they don't even scratch the surface in the level of detail expected from a proper patent. But yeah, I see some companies doing so. It's kind of a protective way and a way of defending a territory sometimes. But anyway, I think those things stay. It doesn't help progress, you know.
Yeah,
Yeah, we could be playing fairly and using less patents as a weapon, I think.
it gets expensive too. Like we're using. I don't want to throw my patent attorneys under the bus, but they are expensive. I don't think they would dispute that. So, but it's a situation where I'll have this argument with my patent attorney over breakfast. Like we've had this conversation so many times where I'm like, do we really need to patent this? And he's like, well, you should. I'm like, but do we really need to? And he's like, yeah, but you should. And I'm like, well, why? And he's like, because it's worth money, and that's how you defend the space. And
Yeah, yeah,
like, all
yeah,
right,
yeah,
maybe we'll
yeah,
patent it. You talk me into it.
yeah, yeah. Well, it can be a crazy game to be played, but I think with robotics, and especially industrial robotics, w- we have so many, I mean, in-depth applications that, I mean, we may be able to use some robots that are out there, but we generally have to develop something new. So I'll give an example, right? Explosive atmosphere. So industrial facilities, I mean, you may have gases around, and the same robots, the same walking dogs kind of robots that everyone uses everywhere, we can't really use them in some facilities, or in some specific areas. And then some companies, I mean, they don't have the interest in investing in making those, say, robots, which are very useful to industrial facilities, because they won't ever be sold 1,000 times or 100,000 times. So yeah, it's working on the niche. Then we gotta find interesting partners who are worried, and they actually give some importance in working with some niche robotics. And yeah, for those niche robotics, then patents or no patents, that becomes a little bit of a, do I really need it, or can I keep it as an industrial secret until a certain time when it's actually off out there?
Yeah, yeah, that makes a lot of sense. I'll do a little bit of both. So there's
Yeah.
I mean, I think the general school of thought's been like mechanical things that can be like 3D scanned and reverse engineered or like better to patent, and then software
Hmm.
things you don't want to patent as much. But then Claude Code comes around, and it's very easy to make software now. And so I'm like, well, is that valid anymore? Like, I don't know.
Mhm. Mhm. Yeah. Yeah. And I guess even using these AIs in general to generate code, or to actually uh, put your code there and ask it to give it a check. It's an interesting topic altogether. How much are we allowed to do so before our own code gets out there and reversed into someone else's queries, or it's a weird situation.
Oh yeah, for sure. The other thing
Yeah.
too is I don't know. I have a friend who works for like a very large oil and gas company, not Shell or not you, but a different one.
No names. Yeah.
Yeah, exactly. And this person was telling me that their company will patent because they just don't want to get blocked by a patent troll. So they'll patent very
Mm,
aggressively just to defend the landscape so they can operate, but then they won't enforce if other people want to do stuff there. So I thought
yeah,
that
I
was an
guess so.
interesting strategy as well.
It may be an interesting strategy. Yeah.
I
It
think they're
may.
just
It
trying to
may.
preserve freedom to operate.
Yeah. It may push some people uh, into a place where they don't want to develop there, but it may push people into trying to reach them out for partnerships, and yeah, and that off you go. It gives you a strategic advantage
Yeah, for sure.
somehow.
That's
Yeah,
also how
maybe.
patent trolls work, right? like,
Yeah.
pay me a royalty, I'll go away.
Yeah. But then you gotta check it. If it's so superficial, so high level, then it's worth nothing. I mean, it's just an idea written on a napkin, really. Yeah.
Yeah, for sure. But sometimes those get like really high valuations for companies. Like there was one company I was examining where we were considering hiring the same patent attorneys that this company used, and
Hmm.
we looked at their patent portfolio because it was a startup, but they had gotten like a 732 million US dollar exit, which
Wow.
is yeah, it's pretty good for a startup. And so
Hmm. Yeah.
so we examined their their patent portfolio, and one of the founders had told me that that was a big reason why they got that kind of valuation. And I mean,
Hmm.
there was the same kind of patents that we're both talking about right now, where they're just far
Hmm.
overreaching, very superficial, but like hundreds of them. So
Hmm.
it's
Hmm.
like you make a web that's that extensive, and I think there is some merit to it, just from the perspective of pumping up your valuation, because it's so much paper that nobody could ever sort through it. Although now with the AIs, maybe that's all changing. You feed it all into
That helps.
ChatGPT. Yeah, exactly.
That helps. That helps. No, but actually, I mean, on my perspective here, which what really matters is, getting robots out there. If the physical stuff, getting it working, getting real value out of it, and if it doesn't work, learn from it. And patents can tell a lot, but life of field experience means much more to me when you're talking about a valuation or company valuation. It's yeah, the intrinsic knowledge that people carry after a few deployments or after a few important uses in the industry.
Well, not to
I mean,
mention just
maybe offshore, yeah,
the market capture and the connections and the sales pipeline that come with that too. I mean, I think that's very valuable as well.
it is having that access to, say, real offshore people, the people who have been working there for like 20 years, just getting out there and hearing a guy saying, it's not worth it simply because it's yellow. Then you learn after 5 years of development that your robot is yellow, and if it was whatever red, it would be much better.
Well, that's not that hard of
And
a fix. Like,
yeah, yeah,
yeah.
crazy examples, right? But anyway, if the guy gets into some, real deep systems interconnection there, then you gotta build your robot from scratch. Just maybe because he didn't like your sonar output, whatever. So yeah, getting the robots out there. That's what really matters. Yeah.
Yeah, that makes a lot of sense to me. And I mean, for sure, just actually like asking the market first and making sure this is something that actually provides value before even spending the engineering effort in the first place, I think is.
Yeah, yeah. It makes a difference. Yeah, just putting your face out there and making the question makes a difference, because there's a lot of people, and hey, we tend to be engineers forever. Like we're not so outgoing. We don't like asking, or we may be afraid of receiving an answer back, which may be negative somehow.
Yeah.
So we tend not to ask, but really, throughout my career, I've been learning that asking more, and even if I get a hit back, is okay. And I've been trying to really be pushy on myself to ask more to the people who have more experience than me in the industry, right?
I think that's smart. I was in the robotics department at Carnegie Mellon, but I was hanging out with the industrial design because I've always been a little bit contrarian, so I wanted to make friends with these other guys. And they had some neat exercises they would do. Like at the time, I mean, this would have been like around like 2010 to 2013. Additive, I guess, wasn't as good as it is now. So I mean, we had 3D printers, but it was more of like a project itself to get one of those to work. And so,
Hmm.
like, what a lot
Yeah,
of them would do
yeah.
is they would carve models out of foam of like hypothetical products, and then they would like sand it and it would be perfect, and they would put primer all over it, and they would get like a feeling for form. And then I remember
Hmm.
they would use gray as the color, because then there was no way you could disguise it with a good paint scheme, and all you would see is the form. And so it was like a purist kind of way of looking at it. I'm sure they're 3D
Very
printing those models
interesting.
now.
Yeah,
Maybe
very
they're still
interesting.
doing it that way, but I bet you they're 3D printing them. Like it's
Oh
just a
yeah,
modern tool.
everyone is. Yeah,
Yeah.
everyone is. And I think what one about 3D printing is an interesting topic to go into. I've heard so many times. I mean, people unaware of the fact that many of the robots we do today, they carry a lot of 3D printed parts. I must say, a lot.
Oh yeah.
And here I am. I'm holding a 3D printed wheel here, a
Nice.
miniature of a valve wheel in my hand.
Oh,
But
that's
anyway,
awesome.
it's so there is this belief in some people that 3D printing or 3D printed parts they are not ideal, or they're gonna break, or they're not gonna be worth it, or even trying it, and people keep using the same old say of 3D printing or additive manufacturing as fast prototyping. And where I'm trying to take or get the industry to is a full acceptance of it, in terms of a finalized robot can be 100% 3D
Oh,
printed,
100%. Yeah.
Yeah, 100%
Yeah.
in all the ways. But still, when I talk with some people, especially some offshore people, they say this is gonna break. It's not gonna survive.
Okay,
Just
so I mean,
wait.
devil's advocate. So if you're trying to keep up pressure, I know like a lot of the way that people do that is just really, really tight machining tolerances and O-ring grooves. How do you substitute 3D printing for that, or do you post machine a 3D printed part, or is it
You
something
just
different?
post machine it, or you just weld on top of it, or I mean there are many different
But it's not
ways. But
100% anymore, then, right? Sorry, this is me
no,
being
it's not
kind of
100%
a troll.
anymore. No.
But
Yeah, no, it's not. But I mean, we getting there. We're getting
for
there. We're getting
sure, for
there.
sure.
Yeah, so robots and 3D printing, they walk hand in hand in many ways, I think.
Well, I think anything where it's a low production volume, right, like makes sense for 3D printing. In some cases, even like relatively high production volumes, like in the low thousands, where people just don't want to carry inventory. Like there's
Hmm.
some awesome, 3D printed parts. There was one that our strategic partner Tronix 3D was making for a big energy company, and it was
Hmm.
just an epoxy injector basically for building generators. And it's a situation where I think the part that wasn't 3D printed was like 10. I think it was like 10 times the cost. Maybe it was 50 times the cost. But a lot of
Yeah.
it was pretty crazy. But like just to
Wow.
3D print them, it got the price way down. And you also didn't have to carry as much inventory because you could make them just in time. So like the warehouse storage fees went way down as a result of 3D printing this part.
Yeah.
So, and I
And I
know
think
like I've been talking to like some of the guys at Baker Hughes as well, and the oil and gas industry, and I mean they seem to have a pretty advanced additive department as well. I don't know if you've talked to those guys at all, but it's pretty
yeah,
impressive.
I kind of talk with everyone, and I
Yeah,
see a
fair
lot of
enough.
people going. Yeah, they going on this direction, which is great, because I was going this direction 10 years ago, and I felt like I was ahead of my time and nothing was happening. But that was really the time when things were at low technology readiness level, and things really got up there when people know what you can do with certain materials, what it cannot be done. Like from a microstructural level, things evolved substantially
For
along
sure.
those 10 years. Yeah, and I think now with robots, uh, if you can get a robot into a country without actually having to physically import or export it,
Oh,
you
that's
have an
amazing.
advantage. You have an advantage
Yeah. Well,
here.
especially I mean living in Brazil, like you guys have challenging customs to get
Yeah,
things through.
maybe. Yeah, yeah,
Not,
yeah.
not to throw too
And
many
and
stones.
no, exactly. And I mean, it's not only Brazil. It's kind of everywhere.
Yeah,
The
that's
other
a good
day we
point.
tried to get a robot into the U.S. and off we went, paying. I don't know. I won't tell you, but it was on the few lower thousands of dollars just to get it in and out of the
Brutal.
country a few days later. So I was like,
We
okay,
got
I could
charged a
have.
tariff on our own actuator that I brought to Europe to show at a trade show, and then I was bringing it back to the U.S. and they charged us
And you were
tariffs.
charged.
Yeah, and I'm like, this was made in the U.S. Like, what the heck, guys? Like, I'm just bringing
You
it
see,
back.
depending on how cheap you can make it, you're better off just 3D print it elsewhere and you
Yeah, exactly.
export it
Just
in a different ways. Yeah.
yeah, for sure.
But anyway, there's all these export controls and stuff. I'm not gonna go into the details here, but there are export controls into digital and software and stuff, right? But really, not having to carry the physical article makes so much difference. It's so much easier. Anyway, yeah.
No, that's awesome.
Hopefully we can 3D print nice, expensive sensors one day, so I don't have to import them anymore.
And I mean, sometimes you still need super expensive parts, but I feel like to use them sparingly is probably yeah.
Yeah,
Or like you
yeah.
said, if you can not use them at all, that's even better.
That's even better. That's good engineering. I was developing some subsea parts in the past, and we had to develop a subsea actuator. And during the assembly of it, it seemed to be all right. Then when we were testing, then it went and it didn't return as expected. So we found that the coil within it, we had a return coil, pretty hard stuff. It wasn't mounted correctly. So the guys, they said, it was an assembly error. And my feedback to them was it was a design error, because if they had designed it right, that coil could only be placed
Poka-yoke.
in one single way. So I mean, and with robots, it's the same. You gotta carry that hardware experience, so you make the software people life much easier.
For sure.
The assembly people lives much easier.
Yeah,
But
exactly.
it's hard to see those. Yeah.
But if you're, a mechanical engineer that's never ever fabricated anything, you probably don't understand, like how to make something that's easy to assemble or fabricate.
Yeah, it comes with experience. It
Yeah.
comes with mounting or assembling a coil in the wrong position. But I think with software, you gotta be careful in not reinventing the wheels sometimes. What I mean with that is sometimes I've seen people, trying to, get a camera view of a robot, and because it was like underwater and there was a lot of turbidity, so there's people working ways of filtering out the turbidity in post processing, right?
Huh. That's pretty cool.
Yeah. I mean, it happens. It happens often. So it's like, but really, if these people have ever used, tools like GIMP, Photoshop, Lightroom, one of those, they would certainly see that you could do this with a few clicks, and you don't actually have to spend like 1, 2, 3 people time for 6 months developing how to remove turbidity out of water
Oh,
in
I see what you're saying
post-processing,
now. Yeah.
Yeah. So yeah, sorry, it was a long look back, but
Yeah. It's all good.
we often see people trying to reinvent the wheel and develop the next turbidity remover feature on your robot.
Yeah, or just something nobody asked for and doesn't want. Yeah.
But if you're not careful, as a project lead, you may end up allowing people to get into those rabbit holes and developing something that already exists.
Yeah, for sure. That makes perfect sense to me.
Yeah. I mean, we all saw some crazy examples in the past, but
I've seen plenty of examples of that, where you're like, hey, dude, put your pencil down. The worst is when you tell somebody, like, hey, please don't do that. And then they do it anyway. And they're like, I thought about what you said. And then I got home. And then I took an Adderall. And then I did it anyway. Don't do that. Like, consuming our budget.
Yeah. People, I heard an interesting one the other day. I think it's the youngest guys, they use these more often than me. So people come into side quests.
Side
So
Oh, I
even
like
at
that. That
work,
actually fits perfectly. They want
yeah, even at work,
the perfect cable management system
it's a
on
side
a
quest
on a
now,
production run of 3. Yeah. Like,
So the guys on a side quest should deliver something which is perfect, but will only be used a few times. Yeah.
yeah, exactly.
But it's us,
Like, that's gonna
engineers.
look
Here I
great in
am,
your resume.
engineer.
Yeah, exactly.
It takes a bit of experience to look at yourself and say, here I am at a side quest that won't add any value. Then, okay, push it out. do something else.
Harder to do it when it's your own side quest. I fully admit that. Like, I think it's much more challenging to see that in yourself than to see it in someone else.
Oh, it is. It is. That's
Easier
why
to
it's good.
listen to somebody else telling you're in a rabbit hole if you trust them. And then, I feel like I don't know, trust is challenging to establish sometimes. There's people that just want to be on their own doing their side quests and won't listen to anyone.
But that's when the end user or the end customer is gonna tell you, I mean, don't worry about it.
Yeah, but they
Focus
might
on
not
something
care,
else.
right? Like, I mean, they might not be adversely
Sometimes,
affected
yeah.
by the side quest, and they might not realize how much money it costs.
Oh
And-
yeah,
yeah.
they want. Yeah.
So they might be like, "Oh, yeah, it's interesting cable ducting. I don't really care." And it's like, well, that costs $70,000 to do. Oh, I care now. Like
Suddenly they care. Yeah.
suddenly they care. Yeah, exactly.
Yeah. But anyway, yeah, side quests in the robotic world, they do exist, and they occur very frequently if you're not careful.
Yeah, for sure.
Uh,
As we're kind of nearing the end of the app, is there anything you want to plug or tell people, or like a company, a product, a message, or just like, hey, be nice to the person next to you, like just something you're thinking.
No, earlier today I was talking with some younger guys, and I think it's an interesting advice that came to mind, and I think it goes well here. It's all about embracing change. It's a crazy world we're living in, and robotics are here to stay. So embracing change in terms of accept we're gonna be developing robots and kind of learn how to operate them, how to use them, or actually understanding how to develop them. That's an interesting way of embracing change in the days we're living today.
Oh, for sure. I want
Yeah.
to see more robotics engineers.
Yeah, so embrace change with robots. That's an interesting final message.
I like that. Oh, Diego, thanks so much for coming on. I really appreciate it, and this was fun. We should do it again.
Oh, thanks, Spencer. Thanks a lot for the invitation. It was great to be here with you.
My pleasure, brother. Thanks for joining us today. If you've made it this far, chances are you'll like other episodes too. Collaborative with Spencer Krause can be found on YouTube, Google Podcasts, Spotify, Apple Podcasts, Pocket Casts, and Radio Public. Subscribe today to get notified when the latest episodes release and support the channel. Have an idea for a guest I should interview? Hop in the comments and let me know who that is. I'm always looking for new people to talk to, and chances are you know folks that I don't yet. Thanks for coming in, and I'll see you on the next one. Collaborative with Spencer Krause is sponsored by SKA Robotics. If you're in the market for elite field robotics expertise, please consider hiring SKA Robotics. They sponsor this podcast and solve some of the toughest engineering problems in the world. SKA Robotics can be found at skarobotics.com.